in a linear equation, remember a straight line equation, we can write that linear equation in a form that immediately identifies what the gradient and the vertical intercept are. The number that is multiplied by the x, we call that the coefficient of the x. The coefficient of the x is the gradient, and the number that is added or subtracted at the end is the intercept immediately. So, if I were to give you this equation and ask you to draw it, immediately we should be able to see that the gradient of this equation is 2 and the intercept of this equation is -4. So, we go to our graph. First of all, we put our intercept in. So these are the steps we go. We put our intercept in first. So it goes at -4. So it's going to cross the vertical axis at -4. And we know that the gradient is 2. And that gradient means that for every one step to the right, it rises 2. So one step to the right, it rises 2. Goes up to here. One step to the right, rises 2 over here. And so that's the line of our equation y equals 2x minus 4. Yep.
What would happen if the gradient was minus?
Let's do it. Okay. What's the first step? We're going to draw. What's the first step? What do I do first? Intercept. What's the intercept? 1. Okay. Okay, so it goes in here at 1. What's the next step? Make another point using the gradient. Okay, so what is our gradient here? -3. So what does that mean?
Do you go across 1 and then down 3?
Across, so we always go across 1, that's right. Always across 1, and because it's negative we go down. So across 1, down 3, down to -2, down to there. So it starts at +1. 1, 2, 3. We're down 3. Okay, if we want to do it again, we go across 1, down 2, 3. We haven't got that much room in our graph. That's okay, we can just still use the 2. That's our line there. Again, not great to scale, but you get the idea. Drawing the intercept. It's always a point we can draw straight away where it crosses the y-axis. It's easy. And then, using the gradient, get another point. And if you want to do it, get a few more points just to confirm we've got it right. But in this case, it wasn't going to fit, so I just did 1 point. -3 gradient means that every step to the right, it drops 3 steps. 1 step to the right, 1, 2, 3, drops 3 steps. Okay. A slightly different kind of gradient now, but again, we go through the same steps. What's the first step? Intercept. Okay. 1, 2, 3, 4. Up here. 1, 2, 3. Okay. All right. So it's at 4 there. Now, what's our gradient? Okay. So, what does that kind of gradient mean? It's not a whole number. So it can still mean the same thing. For every step to the right, we go up half a step. Okay, we can do it that way. And for some of you, that may be the easy way. Or you may think about this now more as your rise on a run. It rises 1 as it runs 2. So as it runs 2, rises 1. Up to there. If you did it the other way, for every 1 step to the right, you go up half a step. Same thing, gives you the same gradient. Okay? Again, not great in terms of our space on the graph, but that's what it is. For every 1 step to the right, rises half a step, or rise, run, runs 2, rises 1, runs 1, rises 2, whichever way you want to talk about it. Here's a graph. What's the equation of it? What is the equation of the line? So remember I said we can go both ways. We can start with an equation, like we've done a few times here, and draw the graph from it, or we get a graph and we work out the equation. So to do that, we say, we need to know the M, we need to know the C. Let's again start with the C. What is the vertical intercept of this line? 2. Okay, what is the gradient of this line? Okay, so we take 2 points we know, and generally those 2 points are where they cross the axis. They're really easy to figure out. So from this point here, as we go, well, what's the run from between those 2 points? The run is 1. The rise is -2 because it goes down 2. Okay, as we run to the right, it goes down 2. So our M equals -2 over 1, -2. So how do we write that in our equation? We just put those two numbers in. Now, -2 goes there, 2 goes up there. Georgia, what's the intercept, the vertical intercept of this one?
1.
Okay, so we've got C equals 1. Now a little bit harder. Taylor, what is the gradient of this? So we'll need to look at rise and run with this. Between the 2 points we know, there's only 2 points we know on this. What's the rise?
1.
What's the run? Well, we always talk positive for run. We go left to right, so it's positive. So it goes from -3 to 0, that's it. It's in a positive move. Okay, so what's our gradient? Rise over run. Now to put those into the equation, anyone want to make a suggestion as to how we can write that? Now, the only thing that we would change about that is we don't normally write 1x over 3, do we? Just x. Yeah. But we understand there's a 1 there, just not written.